Hi everybody. In this lecture, we are going to see how exactly we can perform the heap sort algorithm. So before we are going to sort the data by using heap sort, first we need to understand what is binary tree and what is meaning of max heap, min heap, and how we are going to use this min heap max heap concept for our heap sort algorithm. So when you want to sort the data by using heap sort, we are going to use either min heap or max heap. So max heap means when you are constructing the binary tree, we are keeping the maximum element of left child, right child root in the root place. So we are comparing all the values of left child, right child and root. Among all these three, whatever the element is maximum, that maximum element we are going to keep into the root place. So the same property we are going to follow until we insert all the elements into the binary tree. Then finally it is going to construct the max heap. So by constructing that max heap, we are going to perform the sorting of the data by using heap sort algorithm. First we will take an example. So this is the given data 44, 5, 66, 32, 5, 7, 22, 79, 21, 71. So first we are going to insert all these elements into the binary tree and we are going to make max heap. So first I inserted 44. So this is the only data in the tree, only one node. It is 44. So how exactly we are going to construct the binary tree? First we are inserting the root element, then we are creating the left child, then we are creating the right child of the root. The second element I am going to insert is 5. So now I am inserting 5. So for 44, the left child I am creating and the data 5 is inserted here. The third element is 66. For root right side child I am creating and I am inserting this data 66. So when you are inserting this data, you need to check. So which element is greater among this left child, right child and root. Compared to root, you need to check whether this left child, right child is greater. That greater value you need to copy into the root place. So when you are inserting this new node 66 to the tree, it is greater than to the root value. So we are going to exchange these two values. So 66, 44. So this is creation of the max heap. So where exactly the max heap will maintain the maximum element in the root place compared to its left child and right child. So after insertion of three elements 44, 5, 66, this is the max heap we are going to create. So now I am going to insert the next element 32. So where I need to insert that 32, the left child of 5. So I am inserting the left child of 5 is 32. Now you can compare with the root. So when you are comparing with the root, 32 is greater. So you can exchange these two. So 5, 32. Now you can compare this 32 with the root. Yes, it is less than to root value. There is no problem. So this is max heap after insertion of 32 into the tree. Next, now you can insert the next element 5. So where you need to insert this 5 for right child of 32. For right child of 32, insert 5. So absolutely the left child, right child of this 32 is less than to 32. So there is no problem. So this is max heap. The next element 7 you need to insert. So where we need to insert this 7? The left child of 44. So for 44 left child you can insert 7. Now I am inserting 22. So for right side of 44, the right child is created and you can insert 22 which is less than to root value. There is no problem. So this is max heap. Now you can insert 79. So where you have to insert this 79 for left child of this 5. So you create left child of 5. There you can insert 79. So now you can compare with the root value. So root is 5, the left child data is 79. So you can exchange these two. So 79 comes here, 5 will go there. 79 and its root 32, you can compare. So 32 is lesser value, 75 is greater value. So you can exchange these two. So 32 comes here, 79 go there. So 79, 66. So compare and you can exchange these two values also. So finally the 79 will reach to the root place and its left child is 66 and its left child is 32 and its left child is 5. So this is the final heap, maximum heap we are creating after insertion of 79. Now you can insert 21. The same property we can follow. For 32 right child we are creating and we are inserting 21. There is no problem. It is less than to the root value. Now you can insert 71. So for this 5 left child we need to create. You can insert that 71 here. Compare with root. Yes, it is greater than to the root. You can exchange these two. Then again you can compare this 71 with the root 66. So it is lesser than to the 66. So you can exchange these two. So 71 comes here, 66 will go here and 5 will go here. So accordingly you can update the max heap. Accordingly you can create the max heap. So this is how exactly the max heap will be created for the given data. So we need to follow the property of max heap, where every time the root element must be greater than to its left child and right child. Okay, so this is the final max heap tree we created. From this max heap tree, now I want to sort out data we need to be arranged. So we are going to remove one by one from this max heap to keep the data in sorted order. So first I am going to remove the root element 79. So 79 is removed from the tree and it keeps in the last place of your array. So after removing 79, the last child of this binary tree will be copied into the root. So what is the last child here? 5. So this 5 will go to the root place. So after removing 79, the last child 5 will be copied into the root. So this is the tree you will get. Now you can make this tree as max heap. So now you can check here, the root is 5, the left child is 71, right child is 44. So now you can compare. So 71 is greater here. So you can copy 71 its root and 5 here. Again you can check 5, 32, 66. 66 is maximum. So that can be copied here and 5 will go there. So like that you can rearrange the data and you can create the next max heap. So when you are going to generate the next max heap tree, automatically the next highest element will be placed into the root. So now the highest element in this tree is 71. So now you can remove this 71. So remove this 71, keep in n-1 place of the array. So you have removed 71 from the tree and the last element 21 will be copied into the root place and you can remove this child. So 21 comes here and this is the tree. So again you can apply the property of max heap here and you can rearrange all these elements by applying the max heap property. So 21, 66, 44. So when you are comparing the root element 21 with its left child, so left child is greater. So automatically you can send this 66 to the root place and 21 here. So 21, 32, 5. So when you are comparing 21, 32, 32 is greater. So 32 will go to the root place and 21 comes here. So you can rearrange the data like this. So finally you will get this max heap tree. So now you can remove the maximum element from the tree. So 66 will be removed. So 66 you remove and you place in the array. So after removing 66, the last child 5 will be removed from the tree and this value will be copied into the root. Again you can call the procedure and you can rearrange the data 5, 32, 44. So which one is minimum here? Which one is the maximum? 44. So automatically this 44 you can copy into the root place and 5 comes here. So 5, 7, 22. So 22 is the maximum, 22 will go to the root place and 5 will come here. So 44, 22, 5. So this is the max heap you will get. Now you can remove 44 from the tree. So after removing 44 from the tree, copy this last element 5 to the root place. So again you can apply the max heap property and you can rearrange the elements here. So 5, the root element is 5, left is 32, right is 22. Compared to left and right, the left child is greatest. So 32 will be copied here and 5 will come here. So 5, left child is 21, right child is 5. So compared to these two, 21 will go to the root place and 5 will come here. So this is the final heap, max heap you will get. So now you can remove 32 from root place. So 32 is removed from the tree and you can copy the last element 7 into the root place. Now you can apply this max heap property and you can rearrange the data in the tree. So 7 is the root, left child is 21, right child is 22. So which one is maximum? 22 is maximum. So 22 will be go to the root place and 7 will come to the right child. So this is the max heap you will generate now. Now you can remove this 22. The same procedure you can follow. So 22 is removed from the tree and the last element 5 will be copied into the root place. Again you can check the property of max heap here and you can rearrange the elements here. So 5, 21, 7. So 21, 7, which one is greater? 21 is greater. Automatically you can copy this 21 into the root place. And the left child is 5. For 5, the left child is 5. There is no problem. So this is the max heap. Now you can remove 21 from the tree. And you can copy the last child data 5 into the root. So 5, 5, 7. So again you can re-heapify by applying this max heap property. So the max element 7 will go to the root place and 5 will comes here. So 7, 5, 5. Now you can remove 7 from the tree. So after removing 7, the last child 5 will be copied into the root. So now the root is 5, left child is also 5, both are same. Now you can remove this 5. And finally the child 5 will be copied into the root place. From there 5 will be copied. So this is the sorted data you will get finally. So this is the procedure when I am applying the max heap property for heapifying the data. So similarly we can also maintain the min heap here. So what exactly the min heap property is, always you are going to keep the minimum value of root left child is as root. So you are comparing the root value with left child and right child, and finally you are identifying the minimum element among these three, and the minimum element you are going to keep into the root place. And every time you are removing the root value and you are going to get the ascending order of the data. So when you are using max heap, we are getting data in the descending order. Where you are, if you are maintaining the min heap property, there you are getting the data in the ascending order. So coming to the code, how exactly we can write this code for heap sort algorithm is, take an array A, then you can create the max heap. So when you are creating the max heap, so here I am maintaining the left child, right child, and I am finding the largest element. So largest is I. I is nothing but the root place. Now I am taking the left child of I, right child of I. And I am comparing the values of left and right, and I am identifying which one is greater, whether left or right is greater. So after comparing and identifying the largest element among left and right child, that can be copied into the root place. So this is how exactly the max heap will be maintained. The other function is heap sort. So here I am going to take all the elements and I am sending all these to the max heap. Then one by one element I am going to remove from here. And this is finally the main function where you can read the array A. Then after calling this heap sort, you are finding and you are going to print the sorted data here. So coming to the time complexity, like merge sort and quick sort algorithm, the heap sort algorithm also for all cases it is going to take n log n only, order of n log n. The time complexity of worst case, best case, average case of heap sort algorithm is n log n. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.